Good evening. Today is the second season of our presentation by YaDaiTookTest. For the project description, our project is a POS system that is a full-stack solution for multi-branch retail and restaurant businesses. It manages order, inventory, employees, and customers in real time. And here are the scope along with objectives. Our resources and our selected functions. For mock stop, the first function is get date range. We decided to use stop because as you can see that the function uses datetime.now internally. So stopping fix the date to make the result deterministic, right? Next, get inventory flow. We decided to use stop because the goal is to verify correct weekly grouping of stock rows. So stopping inject fixes row and freeze the date, keeping the test deterministic without testing fast API internal. For update branch, we decided to use mock because the function contains db.commit and db.refresh. So write operation that must be verified as called, since a missing commit means the update was never saved. For delete ingredient, we decided to use mock because it has both db.commit on success and db.rollback on failure. We must verify which one was called depending on the scenario. And the last one, create recipe. We decided to use mock because it has db.add, db.commit, and db.refresh. Thus, we must verify all three were called on the new recipe creation path and db.commit on the increment path.
So now we'll move on into unit testing. First test case is get date range. It takes a period string and returns a start and end date time tuple. We tested in 6 input: 2 days, 7 days, 30 days, 1 year, or an unrecognized string. The fixed mock time we use is year 2026, month 4th at day 3 at 3 o'clock. So with today's start becomes midnight of at the same day and end is 3 o'clock. With 7 days, start goes back exactly 7 days to March 27. All goes all the way back to 2020, month 1, date 1. And for anything unrecognized, it falls back to the 30-day range. Same result as 30 days, all 6 test case pass. The second one test case is get inventory flow. The function retrieves 52 weeks of stock movements and groups them into weekly usage and restock totals. We tested in 3 input: restock only movement, usage and sales movement, and a mixed multi-week dataset. For the restock case, 2 entries of 150 in week 14 should total 150 in the restock bucket. For usage and sales, 30 and 20 in the same week, total 50 in usage. The third case checks that the final output is a list sorted ascending by week name. So 2026 week 6 come before 2026 week 14. All 3 cases pass. The third one is update branch. This one validates phone format, checks for conflicts with the active memberships, and applies the update. We tested 6 scenarios: valid, update with a new phone, branch not found, invalid type phone format, phone already used by an active membership, unchanged phone where the conflict check should be skipped, and updating multiple fields at once. For the valid case, the branch comes back with the updated name and phone. Not found gives 404. Invalid format gives 400. Phone conflict with an active membership also gives 400 with the conflict message. Unchanged phone skip the membership checks entirely and just return the updated branch. Multi-field update returns all the news value together. All 6 tests pass. Phone 1 is delete ingredient. It soft delete the ingredient and cascade to mark all related menu item as unavailable. For scenarios, deleting an active ingredient that's mapped to recipes, a non-existent ID, an already deleted ingredient, and a DB exception mid-transaction. For the normal case, ingredient ID 1, which is salmon, guess is deleted set to true, and menu item ID 101, which is salmon sushi, guess is available set to false. Then returns the success message. Non-existent ID gives 404. Already deleted returns early with ingredient already deleted, and on a DB exception, rollback fires and the function raises HTTP 500 with the error detail. All 4 cases pass. The last one is create recipe. It either creates a new recipe entry or increments quantity per unit. If the combination already exists, we test 4 scenarios. Valid new combination with an active ingredient, non-existent ingredient ID, a soft deleted ingredient, and a duplicate menu item ID plus ingredient ID combination. For the valid case, a new recipe is created with menu item ID 202, ingredient ID 1, and quantity per unit 0.5. Non-existent ingredient gives 404. Soft deleted ingredient gives 400 with the message, cannot add deleted ingredient expired nor to recipe. And for the duplicate case, quantity per unit increments from 1 to 1.5 in the existing entry instead of creating a new row. All 4 pass.
Next is system testing. First test case is system can generate sales and trend reports. The test case will verify that the dashboard display accurate sales charts and metrics correctly filtered by date range and sale category. And there are some prerequisites where we need to run the Docker according to the README in the repo and see the data first. Here are some test steps, and the result is that the system successfully updates the dashboard data to perfectly reflect the applied date range and sale categories. Next is a test case where system can adjust an ingredient amount in the inventory. It will verify that editing an ingredient amount is reflected immediately in the inventory tab with a matching adjustment for the log entry. And the result is that the ingredient amount is successfully updated and the most recent inventory log correctly reflects the exact adjusted quantity. Thirdly, system can manage branch and employee. It verifies that a branch can be created, assigned, an employee, rename, and delete with all changes correctly reflected in the system. There are some steps and data to it. The actual result is branch creation, employee assignment, branch renaming, and branch deletion operation all execute successfully without any errors. Next, system can manage ingredient. This test case will verify that an ingredient can be created with correct details, edited, and permanently deleted from the system. Here are some steps, and the result is that the system successfully executes the creation, editing, and deletion of specified ingredient without any errors. Lastly, system can create recipe and take it into the order. It verifies that a new menu item with a map recipe is correctly saved and immediately available for selection when creating a new order. Here are some steps, which is quite complex and long for this test case, since we are trying to create new recipe and check whether it can be used or not. And the result is that the recipe is successfully saved with correct ingredients and the new menu item appears and functions correctly when creating a new order.
In this slide, we present the verification result of the work process. Verification focus on ensuring that we follow the correct development and testing procedures. We verified key processes such as documenting the project descriptions, defining the mock and stop strategies, creating test cases, and also establishing the traceabilities. This slide shows the verification of the work product. Here we evaluated the actual outputs of our work, including the project description, test plan, mock and stub strategies, and also the traceability matrix. All items are also correct, meaning they meet the required quality and are completed. This can confirm that both our process and deliverables are correctly implemented. Now we move to validation. While verification checks if we build the system correctly, validation checks if we build the correct system. In other words, validation ensures that the system meets user requirements and work as expected in real scenarios. In this slide, we present the first part of the validation result. We tested whether the system correctly handles order creation and workflow, payment processing, and membership point dedication. We also verified that inventory is automatically updated based on receipts when orders are completed. In the final validation slide, we show the remaining requirements. The system supports full crowd operation for menu items and receipt management. It's also correctly managed branches and employees, including deletion and data consistency. Additionally, the dashboard provides accurate sales reports based on filters such as data range and categories. All results are correct, confirming that the system fully satisfied the project requirements.
Next, it's question time. For the first question, there are 3 sub-questions. When you choose between mock and stop for a function, what was the deciding factor? Stop supplies canned data to the function, used when you need values to test logic, while mock records how it was called, used when the goal is to verify an action. And if your function depends on both a database query and internal logic, how did you isolate which one was responsible when a test failed? So here is the isolation. So the setup is that we have to replace the database with a stop returning known data. And for the diagnosis, if it failed with stop, then the bug is in your internal logic. But if it passes with stop but still fail in real database, then the bug is in the query or schema. And what would a different choices of mock or stop have made that diagnosis easier or harder to automate consistently? Here's the thing. Mock are brittle. They track how code works, right? Changing internal names can break tests even if the result is correct, so it is harder to automate. While stops are stable. They track what code produced and they keep automation consistent during refactor. This made it easier to automate. And for the next question, how many distinct input dimensions did you identify? For delete ingredient, we identified 3 of them, which are ingredient existed, deleted status, and DB outcome. And did you verify that every meaningful pair of those dimensions was covered? For this question, not fully. We covered most of them intuitively, but didn't formally check every pair. Most combinations were there, but few slipped through. And if you find a missing pair now, what fault could it have failed to detect? So the missing pair is not X plus DB crash. Right now we assume the query just returns none clearly when the ingredient doesn't exist. But if the DB throw an error during that lookup, we never verify whether rollback actually gets called. That could hide a bug where the transition is left in a broken state silently.
Well, again, there are 3 sub-questions. Is there any requirement in your project code covered by a system test but with no corresponding unit test? Well, no, all 5 functions are tested in both system and unit test. Next, what is the risk of signing off that requirement when its unit level behavior has never independently verified? So if there are no independently verified unit testing, it would cause the whole system testing to fall apart, making undetected failure to lead to the production, and use cases might fail as well. Lastly, how would you close that gap before execution? Just add a unit test for aggregation function directly, stop the database with fixed order data, and assert the total come out correctly. Question 4. First part is, if a unit test for one of your functions failed, but the corresponding system test for the same feature passed, how did you interpret that result? The fault was still there, just not triggered by the system test inputs. I treat the unit test failure as ground truth and did not consider it resolved until the unit test passed. What does it tell you about how you would design your regression test suite going forward? Every identified fault needs a specific unit test case targeting that exact condition. System tests cannot substitute for this because their inputs are too coarse to reliably hit specific faulty path.
For the last question, we have 5 sub-questions. So the first question is, pick one condition from any of your tested functions. So we're gonna use delete ingredients as our example. And the second question is describe the specific mutation you would apply. The answer is like the condition we gonna mutate is the early return check. If DB ingredients is deleted, if we flip it to if not DB ingredients is deleted, test case 1 would actually catch it because the function would skip the soft delete and just return early, so the test will fail right there. The third question is also explain whether your current test case would detect it. So the trigger mutation is changing the query feature, so it's only 5 ingredients that are already deleted. That one could slip through because we were mostly checking what the function returns, not actually verifying that each deleted got set to true on the object. If the mock is too loose, it just passes and we never notice. And the fourth question is, if not, what input values would a killing test case require? To kill that mutant, we need a test that explicitly checks that its deleted was actually flipped to true after the call, and that the related menu items really got marked unavailable, not just that the success message came back. And the last question is, why was that case absent from your original suite? The reason that test wasn't in our suite is pretty simple, so we were thinking about outputs and exception, not about whether objects themselves were actually changed. We checked what come back but didn't look closely enough what happened internally.